Exercise 7D is looking at determining what transformations have already happened. So this time we're going to be given an original equation and then given the equation of the image and asked to find out actually how do we get there. So what transformations have happened. So let's look at a really basic one to start off with, y equals x squared. And then from there, let's go to a new equation in y equals, let's say, negative x plus 1 all squared plus 2. So what transformations have happened to get us to this new equation? Now, what I would do, and this is my method of working out, is add in the image dashes into your second equation. So we know that this one now is the image, and then we're trying to make it look as close as we can to the one up the top here. So this one has y equals x squared. So on the right-hand side of the equation, we've just got something squared. The second equation, we've got a little bit extra out here. So I'm going to move everything away from it, so I just have something squared on this side. So I'm going to move that plus 2 over. So I have y dash minus 2 equals negative x dash plus 1 all squared. And then move them negative over as well. So I'll end up getting negative y dash plus 2 equals x dash plus 1 all squared. By doing that, we can now say that this original equation x is now equal to the image plus 1. So therefore, x equals x dash plus 1 and y equals negative y dash plus 2. So if we're writing this in our image notation, we'd say xy maps to x dash plus 1 if we wanted to. Let's move this over actually. So I should actually expand this out a little bit further, shouldn't I? Make the image the subject. So if x equals x dash plus 1, I want this image up here to be what happens to the x. So that become x minus 1 equals the image. So x minus 1. And then my y dash, which was y equals y dash plus 2. There was a minus there, wasn't it? Sorry. So that becomes y minus 2 equals y dash, negative y dash. So therefore, out the top here, I would have negative y plus 2. Then it just has to, we just have to list the transformations happen. Now, the order, I remember a little acronym, Dr. T. So list your dilations first, then your reflections, then any translations have happened. So if we look here, is there anything multiplying? There's no dilations. There's nothing multiplying x, nothing multiplying y. Is there a reflection? Yes, there's a negative times this y here. So there would be a reflection. Now, if it's multiplying the y, that means there's a reflection in the x-axis. Remember, the dilations and reflections swap over. So that's accounted for that negative. And then translations, I've got a minus 1 here and a plus 2 here. So it doesn't matter which order they go in. We say there's a translation of 1 unit. Now, this one here, minus 1. So it's in the negative x direction, which we all know is left. And then the last one is the plus 2 out here. So a translation 2 units in the positive y direction, which is up. Let's look at a more complex one. Okay. Let's try that same technique. And let's go with a little less usual equation to start off with. So I'm just picking one from exercise 7D. Let's look at y. I'll write this nice and big for you. Y equals 5 on x minus 3 all squared and we want -7 to get to the graph of y equals 1 on x squared. So we've got this equation here. Now we're trying to see how do we transform that into our standard 1 on x squared or truncus graph. So normally we've gone from this simple one to here, and we might go, yeah, this one's gone down 7. So looking at it, we go, well, to get back up to the top, we have to go the opposite, up 7. And so when we're trying to do it without doing all the notation, we can sort of make little mistakes as we go through. So let's put our image dashes in our second equation, and let's try and make them look as similar as they can. So I just want everything on the left here to be in terms of y, and then I just want 1 divided by something squared. So I've got to move all this other junk, the 3, 7, all this sort of stuff away. So let's plus the 7 over. I would get y plus 7 equals 5 on x minus 3 all squared. And I go, well, I've still got a 5 there. I want it to be a 1. So let's divide both sides by 5. So I get y plus 7 on 5 equals 1 on x minus 3 all squared. And now I've got 1 on something squared equals to something in terms of y, just like what the equation here. So let's set up our image notation equations. So that's our question there. So my image, y dash, is equal to y plus 7 all divided by 5, which I could write as 1/5 multiplied by y plus 7, just so it's in one nice little line there. And then the x values, I've got the x dash is equal to x minus 3. So here's my two equations for the images. Let's rearrange those to make x and y the subject. So I'm going to call this, no, I don't have to call it equation 1, do I? So y dash equals 1/5 y plus 7. So that'd become 5 y dash. I actually don't need to do that, do I? No, this is good because it's already in terms of image. So all I have to do is go x, y maps to x minus 3, comma, 1/5 y plus 7. Okay, then listing our transformations. So therefore our transformations would be, remember, Dr. T, is there a dilation? Yes, there is. The dilation of 1/5 here. So there's a dilation of factor 1/5 from, now it's multiplying the y, so it's going to be from the x-axis. Okay, and then my second one, I've got my dilation there, and then I don't have any reflections. So now I just list my translations. So I've got a translation of, now let's do our x ones first. We've got 3 units in, it's going minus, so it's going the negative x direction. So the negative x direction, or left. And then we've got a translation of this 7 here, 7 units in the positive y direction, which is up. Okay. So steps, just to refresh. Put your image dashes in your second equation. Set up your equation for the image of x and y, and then once you've written your original equation, or your original values x, y, your original ordered pairs, and then they map to, put in your new values that you got from here, and then when you're listing your transformations, remember Dr. T, list any dilations, then reflections, then translations. Okay. All right. Good luck.